The progression of scientific knowledge is commonly portrayed as a triumphant march from ignorance to enlightenment, with luminaries like Galileo, Newton, and Einstein serving as pivotal markers. But behind these towering figures lurks a multitude of forgotten scientists, individuals whose breakthroughs or bold hypotheses were ignored, overshadowed, or actively suppressed. Their stories illustrate that knowledge often evolves in fits and starts, shaped by politics, personal biases, or sheer happenstance. Just as importantly, some wild theories advanced by these lesser-known thinkers occasionally prove prescient or serve as stepping stones to future revolutions. Consider the case of Mary Anning, 1799 to 1847, a self-taught paleontologist from England's southern coast. She discovered crucial fossils, including the first complete ichthyosaur skeleton, contributing immensely to emerging theories of extinction and Earth's deep history. Yet due to her humble origins and gender, the male-dominated scientific institutions of the day rarely recognized her accomplishments. Anning sold her finds to museums and collectors, inadvertently letting more prominent scientists reap the academic glory. Only years after her death did the Royal Society acknowledge her pivotal role, reflecting an all-too-common pattern in which brilliant minds outside the establishment languish uncredited. Another overlooked figure is George Robert Fitzgerald, an Irish eccentric who in the late 18th century dabbled in early electrical experiments that were largely dismissed by colleagues. While the documentation is spotty, he lacked stable patronage and official credentials. Fragments suggest he toyed with the idea of harnessing electricity to transmit signals over distance. Had he found more mainstream acceptance, he might have foreshadowed parts of telegraphy decades before it took off. Instead, his lack of formal connections and personal controversies, including legal troubles, meant that his notes languished unexamined until well after his death. Gender biases historically shut out many women scientists, from the mathematician Hypatia in late antiquity, who faced hostility in Alexandria, to modern times when female physicists or chemists worked as assistants or behind-the-scenes contributors. Some advanced key concepts, like Lise Meitner's role in discovering nuclear fission, yet had Nobel Prizes pass them by in favor of male collaborators. Today's scholarship attempts to retroactively give them their due, but the damage of decades or centuries of omission lingers, revealing how scientific progress is often shaped by prevailing social hierarchies rather than pure merit. In some cases, scientists advanced theories that seemed absurd initially, only to gain partial vindication later. A 19th-century mathematician might propose non-Euclidean geometry, ridiculed as a meaningless curiosity, yet crucial for Einstein's relativity. Another might speculate about the existence of continents that once fit together, preceding Alfred Wegener's continental drift concept, later plate tectonics. Indeed, ideas akin to Wegener's occasionally arose in the 19th century, but lacking compelling fossil or geological evidence, they were dismissed. Wegener himself faced harsh criticism from geologists for decades, only to be posthumously validated when seafloor spreading and subduction zones were discovered mid-20th century. Wild theories can also refer to notions that remain unproven or remain fringe. One example is Immanuel Velikovsky's mid-20th century proposition that planet Venus was ejected from Jupiter and passed near Earth, causing historical catastrophes recorded as myths. Most astrophysicists dismissed Velikovsky's claims as nonsensical, lacking viable gravitational or orbital mechanics. Yet his popular books sparked debates about whether mainstream science was too quick to squash unorthodox views. This conflict revealed the boundary between legitimate scientific skepticism and the possibility that consensus can ossify if not regularly challenged. While Velikovsky's celestial upheavals remain unsupported, His emphasis on cross-cultural mythic parallels seeded new dialogues in comparative mythology. On the flip side, some forgotten scientists championed ideas that turned out to be correct, but were overshadowed by rival schools. In biology, Lamarck's notion of inherited characteristics was sidelined in favor of Darwinian natural selection. While Lamarckism, as originally framed, is largely discredited, the emerging field of epigenetics shows that environmental factors can influence gene expression in ways that mimic inheritance. Although this doesn't confirm Lamarck's exact model, it hints that even obsolete theories sometimes contain kernels of insight that, refined by new data, resurface in unexpected forms. Further complicating matters, political climates can hamper scientific recognition. In the Soviet era, research that contradicted Lysenko's agronomic doctrines was deemed bourgeois pseudoscience, causing geneticists to be purged or silenced. Similarly, in other regimes, entire lines of inquiry were discouraged if they didn't align with state ideology. This stifling environment ensured many bright researchers fell into obscurity, their contributions unearthed only after political thawing allowed open scholarship again. Language barriers also cause overshadowing. A revolutionary paper published in an obscure language or in a local journal with limited distribution might remain unknown internationally. Generations later, historians might discover that a little-known mathematician in Eastern Europe solved or anticipated a crucial theorem before it was officially discovered in Western Europe. The world thus recognizes only the name with broader distribution, leaving the originator anonymous. Even geography can play a role. Scientists in remote regions lacking strong academic networks historically faced hurdles in disseminating their findings. Why bother unearthing these overshadowed figures and unorthodox theories? For one, it corrects the historical record, granting a more inclusive and accurate account of how knowledge evolves. This broader perspective can also spark fresh inspiration. By revisiting older lines of thought, researchers might see new potential in half-formed ideas. The cyclical nature of scientific paradigms, where one generation's heresy can become another generation's orthodoxy, reminds us to approach consensus with both respect and critical openness. Some modern institutions have begun awarding posthumous honors or renaming concepts after neglected pioneers. Online archives digitize old treatises, making them newly accessible. Citizen researchers occasionally delve into historical documents, shining light on forgotten geniuses. Meanwhile, universities hold symposiums on the uncelebrated visionaries of their fields, revealing that scientific progress is as much about social acceptance and recognition as it is about logic or empirical success. Still, caution is warranted when championing wild theories. Some remain tangential at best, like persistent claims of perpetual motion machines or untested free energy devices that defy established physics. Being ignored by mainstream science doesn't inherently validate an idea. However, the line between rigorous alternative hypotheses and baseless speculation can be fine. Distinguishing the two involves thorough peer review, reproducible experimentation, and theoretical coherence. In sum, the tapestry of scientific evolution is woven with the threads of overshadowed discoveries, neglected innovators, and radical theories once dismissed as lunacy. By revisiting these neglected chapters, we see that the pursuit of knowledge rarely unfolds linearly. It's a dynamic interplay of curiosity, institutional acceptance, personal ambition, and sometimes mere chance. Recognizing history's forgotten scientists fosters humility, reminding us that we stand on the shoulders not just of giants, but of countless unnamed figures who also pushed the boundaries, often at great cost or with little reward.